is I have no idea where it um, is storing it.
Yeah, we can figure it out.
Yeah. Those others are recorded to the cloud, and I don't know how to get
It'll pro
those
it'll
on.
probably be in Jen's Zoom cloud, maybe.
Yeah. Well, I've got the emails and the codes to access them. I can watch them, but I can't download them.
Right. Yeah, that's
And
and that's what we need to
therefore,
do.
yeah, I don't know how to get them to comms to to put on YouTube or anything like that without the hard, excuse me, the downloaded copy of it.
Yeah, I'm working through it. I'm gonna try to figure it out. I may just have to do like some type of extraction from that website version.
Yeah.
But yeah, let's see what happens when you save it to the desk to your computer.
Okay. Oh shoot. Um, I'm leaving my computer. I wanted to ask you. My computer's been acting real weird. I talked to John this morning. And he said that he would take it for me and just reformat the hard drive
Hmm.
over the next couple of days. Number one, I wanted to make sure that it's okay if I. He said they don't have any backup or loaner computers. So is it okay if I use my MacBook tomorrow and Monday or tomorrow
Yeah,
for
that's
work? Okay, I just wanted to make sure. And then I will find this recording and put it on a flash drive before I hand my computer over to him because I would hate for that to be erased.
Oh yeah, true. Okay, that sounds good.
I just have no idea where it would even.
Hey now.
Hey,
Welcome back.
Oh, goodness. All right. Now, y'all just tell me when to start rolling. I'm with y'all.
alrighty. We'll give it about 5 more minutes, and if nobody happens to hop on, we're just going to act like they did and just go right through it. We usually have pretty decent crowd though. All right, Dr. Barrett, you ready?
I'm ready to roll, my man.
All right, here we go. Hello, everyone. My name is Ben Payton, and I'm the Senior Technical Assistant Specialist for USET's Office of Environmental Resource Management's Lead Reduction Program. We offer sampling, training, education, and community outreach to all of our 33 nationally recognized tribes that we represent. Today, we are continuing our lead reduction virtual trainings, but in this series, we will be discussing what happens beyond taking action. The final T in EPA's three T's for reducing lead in drinking water in schools and childcare facilities. And each session, we have invited a subject matter expert to present their experience with different types of remediation, from replacing plumbing, bubbler stations, all the way to installing filtration systems. Today's subject matter expert is Dr. Jason Barrett. Dr. Barrett is originally from Bobo, Mississippi, a small farming community south of Clarksdale, Mississippi. He now resides in Starksville, Mississippi, with his wife and four kids. Jason began his Mississippi State University extension career as a graduate assistant in the Food and Fiber Center. Dr. Barrett went on to work for the Agricultural Economics Department as an extension associate and furthered his career as an extension instructor and then an assistant extension professor with the Center of Government and Community Development. Now he is an assistant extension professor and interim director with the Mississippi Water Resources Research Institute, where he specializes in public utilities, that's water and wastewater, private well education and screening, and leading the Mississippi Well Owner Network. He also leads the lead testing in schools and child care centers program for Mississippi. Other research interests include financial and economic development factors associated with water and wastewater utilities. Today, Dr. Barrett will be discussing testing and remediation efforts of the state of Mississippi State University's SIP Safe program and the variety of remediation solutions that the program has put into place. Feel free to drop questions into the chat or raise your hand. We will do our best to answer them to the best of our ability. There will be a Q&A session at the end of the presentation. With no further ado, I give you Dr. Jason Barrett.
All right. Thank you. I'm assuming y'all can hear me well. I'm share
I
my
can hear you
screen.
fine.
Okay. So I'm sharing screen. All right. Can we see?
Not just
Say
yet. I
not
think it's
yet.
still loading.
Yeah, there it
Here
is.
we go.
Okay.
All
All
right, you're
right.
good to
Good
go.
deal. Well, as Ben and Jakira said, I'm Jason Barrett here with Mississippi State University Extension. Uh, Glad to be on. I appreciate the invite. I especially enjoy the opportunity to talk about any of the programs that we're doing in the state of Mississippi relating to lead testing, lead remediation. Our program, we pulled it from Mississippi, and then kind of the play on words of sipping water. Our mindset is if we potentially have future programs, we may want to kind of play off of that. But anyway, our program here in the state of Mississippi is SIP Safe, and it is one of the 50 programs across the country under the WIN grant, lead testings in schools and child care centers. And today we are going to be talking. This thing. Yeah, today we are going to be talking about lead, is where we thought it would be, and our remediation recommendations. All right. So to jump into the program, of course, you heard Jakir talking about three T's, training, testing, taking action. This is something that's kind of a foundation of our program. What we've done since the inception of the program, we had a test, kind of a pilot program back in 2016, in which we were sampling at just a handful of facilities. mainly looking at different type of lead testing instruments, field instruments if we could, and then we rolled into this program, the Wind Grant, in which started in officially 2019, and we all know what happened the spring of 2020. So we were, kind of stuck for just a little bit in the office and not being able to get out into the field. So we created a good many publications, which I think was ultimately good for us. Uh, what I wanted to start out with is I'm gonna say maybe hopefully dispelling a couple of assumptions that we see across the state, and I'm sure it rolls over into other states. When we start thinking about lead, who is vulnerable and how are they getting lead into their body, ingestion? Um, Typically the birth to 6 or just under 6, those are the most vulnerable that we find. But I like this chart, and I've got another one that goes just a little older, where we start to see that people can be exposed to lead through food, soil, dust, paint, and water. Some people believe and have the assumption that water is the sole source that people can ingest lead. And knowing some of our water chemistry people, you're not getting it from a raw source. The adjustment of our pH is what enables us to try to keep the water lead free, because the pH being lower, being acidic, stagnation in certain types of pipes allows those leads, coppers to leach into the water. So just knowing that it's not necessarily lead itself from the source, but we're looking at our pH, and then from here also looking at the different manners in which children become exposed. And we see these graduated bar chart here. And then as kids get a little bit older, water actually becomes less of the reason that we may see those blood lead levels be elevated in children. All right. Talking about, our program before we get into the remediation piece, and I wanted to kind of set the foundation of why we did what we did and leading into our remediation efforts. But if you think about where to look, if you think about if I'm going to target areas, if I'm going to target schools, I'm going to target childcare facilities, where do I need to look? So the publicly accessible places for data, our state primacy agency, which is the Bureau of Public Water Supply, Mississippi State Department of Health, they're going to have water quality data. So they're going to have annual or every 3-year data from water systems that are doing their uh, lead and copper results. So they should have systems where they know if there's an elevated lead level. So from a water supply standpoint, and then our local county health departments that would do any type of blood testing within children. So they're going to have the numbers or blood lead levels in children. So we got those two data sets and we overlaid. And if you can see, based on our state, the red counties are counties in which the county health departments had data that showed elevated blood lead levels, and there were public water supplies uh, that had elevated lead in their drinking water. So the yellow is simply ones that had lead in the water, but no blood lead levels elevated within the state. So this was our initial kind of target of counties. This is not necessarily where we are now, because again, it's a statewide program, and I believe we've been in 54 of our 82 counties now. So it's completely voluntary. It is completely free to the system. So again, it's open to any of these systems. All right. When it came to recruitment, again, trying to get into these facilities, because as we've seen with this expansion of the lead and copper rule, we're starting to, I'm going to say, really hone in on the areas in which the children are most vulnerable. So where are the children? Where are they spending the majority of their day? So you think about childcare centers and schools. So schools are pretty easy as far as to get the listing, so we know who they are and where they are. Child care centers, most states, as ours does as well, has a child care licensure as part of its state health department. So it's fairly easy to get the list of the centers within the state. So we'll start to have a very defined list of our schools, very defined list of our child care centers, so we know who to target. When it comes to other information that we may be pulling, because we never know where these programs may be or the research we may want to do. So we were always collecting the water source, whether it's private well, public utility, the building type, whether it's a commercial structure, residential that's been converted, data construction. Mainly we get that, so we're knowing whether it's a pre-1986 or post-1986. Date of any type of renovations, because we think of those as when any type of plumbing may have been updated or brought up to code. So there may have been some change in plumbing materials, enrollment in the program when these facilities participated with us. All right, getting our sample time and dates together is the logistics of collecting samples is the most time-consuming part of the program itself, simply because we're offering a service. That doesn't necessarily mean everybody that we're working with or dealing with sees it or realizes the importance of having these lead tests done for the drinking water. We may all think it's important, but they may not necessarily either think or know any reason that should be important. So again, the logistics is very time consuming. What we try to do is get down to a facility the evening before and after everybody leaves. As far as children go and workers, we try to flush every faucet that's going to be tested, which we try to test all faucets. Turn the cold water side on, flushing into the system, into the facility, hopefully a very uniform treated water so that we have the exact same age and quality of water stagnating in these faucets and fixtures overnight. And then we get in the morning before the next morning before anyone else arrives. So we try to have at least an 8 hour stagnation. Sometimes it's a little bit more, and that's okay. I mean, it's all within that range of probably 7 to 10 hours of stagnation that we see. But we do collect 250 milliliter sample bottles, first draw from every single faucet within a facility. I was very adamant when we were starting this program that we may end up testing fewer facilities than our counterparts across the country, but I want to test every faucet within the facility. So we're finding that our faucet testing numbers or our sample numbers are similar, per capita, but we may have fewer facilities because some of our counterparts will just test two faucets in a facility where we're testing all faucets within these facilities. So again, we'll go through in the morning, collect all the samples, one for each faucet. And then we have two state certified labs based on the EPA 200.8 method for testing of lead in drinking water. One is on campus with us, and that is our primary target for samples being run. That's the Mississippi State Chem Lab. And then once those samples results come out, the state chem lab sends them to us. They go straight into our database, and then from our database, we are producing a results letter that goes specifically to the facility. And this is where we start getting into kind of some remediation efforts, because on those results letters, we will highlight anything that's at or above 5 ppb, even though we look at 15, and 15 used to be our kind of our benchmark, where now it's 15 it's moved to 10 as an action level. We use 5 as our program kind of internal action level that we'd like to see. So if we see anything at 5 or above, we'll notify the facility of that faucet that we've seen. All right. Across the state up until the end of, and we're bearing down on another year, but at the end of fiscal 24, we had 226 facilities, 18,365 children enrolled in the facilities that we were testing, collected over 4,000 samples. We had awarded 275 continuing education units, and we'd been in 54 of our 82 counties. All right. So getting into the breakdown of what we've seen. Again, this is coming through the end of September 2024. I try to keep this on an annual fiscal year with our program itself. So at the end of September 25, we'll update all of our numbers and our PowerPoint as we may move forward with this data here. So 54 of our counties have participated, so that's 65%. So you can kind of see where we have not been in our state. This isn't for a lack of trying or effort. When we think about promotion, we've sent out postcard mailers, we've sent out emails, we've sent out flyers, we've sent social media posts, we've attended trade association meetings, and we pick up the phone and call people. So it is an effort. All right. When we think about date of construction, you can see my kind of line in the sand here, uh, 86, 87. So 51, 57, 51 of, but 57% of our systems facilities that we've got data for were built on or before 1986. And I think it's interesting that we see that the average age of those was built, or the average year was 1962. And then post 1986, the ones after 87, are that average year is 2004. But I like this just because we will probably down the road look to see if there's any correlation between pre and post as far as the lead exceedances we are seeing in these facilities. All right. Child care facilities that we've tested in the state, we have got 1,500, and this number bounces back and forth just a little bit as we pull this every probably every quarter. It may be a few higher than 1,500, it may be a few lower than 1,500, but it's around that area. So looking at facilities tested, so we've only hit about 13%, which is not a whole lot in the grand scheme of things, but that is where we are. I'm gonna go back to this, but we are getting to a point where we feel like we've got a pretty good representative sample just because we're covering so much of the state, and we're actually starting to get multiple facilities within each of the counties. So I feel like we're in this kind of the dam is breaking standpoint where you're getting into more facilities, and it's just kind of opening up a little more and a little more. All right, types of facilities you heard me talk about: commercial and residential. And one would think, as I have, that building materials may kind of dictate some type of testing results or sample results. And a lot of our commercial facilities aren't necessarily new. And then as far as even our residential locations, as you saw, average age, if they're older than 1987, is in the 60s. So it's very possible, we have old infrastructure, old plumbing that may be serving a lot of our child care facilities in Mississippi. All right. First draw samples. Now this is total, so this is of all of our samples. And I would say, if anything, our data is, to me, should give us some peace, give us a little bit of peace of mind across the state as far as what we're seeing and the safety we may have for our kids. So of all of our samples, of all the facilities up till now, you see 50% had zero detection Another 39% were below the 5 ppb. So if you put that, I mean, we're bumping on 90%, well below, any type of threshold or metric. But if you get into the 5 to 10, another 5%. So we're right there at 94% or below, any type of action level that we would see if we were reporting this from a regulatory standpoint. All right, this is just another visual on it from a bar chart standpoint. Again, you see the long blue line at the bottom, non-detect, the next line up, orange, less than 5. So we have a huge amount where we're getting literally zero detect or very minimal that wouldn't even uh, necessitate any type of announcement or notification or additional sampling. All right, so this is where we get the breakdown, and this is where we start thinking about, I'm gonna say, our remediation efforts. Because when we look at a facility, and I've got um, another slide here in a little bit where I'm gonna kind of walk through all of the kind of plumbing components that water may be exposed to before it enters a home. We're simply collecting the first 250 milliliters, which is what is actually sitting inside of the faucet itself. So that's what we're actually testing. We do some flush draw samples when we go back for a second round of checking for ones that have actually had an elevated level. So bathroom sinks, so 50% have a non-detect, and then you have 40%. So we're at 90% again that are less than 5 ppb. And then you've got another 5% that are less than 10 ppb. So again, based on the bathroom sinks, we have 95% that are again below any type of actionable level that you would see or have to do any type of reporting for. Moving on to hand sinks. Majority of our childcare facilities will actually have sinks inside of the room themselves. So not only do you have sinks in the kitchen, sinks in the bathrooms, but there will be little hand sinks inside the room. Now you may ask, hey, why would we want to sample those? That's a hand sink. Well, in my mind, and from everything I've seen, we don't need to assume that no kid would ever drink water from any of these faucets or fixtures, just because of kind of their location. So very similar sample results: non-detect 49%, less than 5, 40%, under 10, 5%. So we're around that same benchmark of 94, 95% below any type of regulatory threshold. Kitchen sinks. Now you see a little bit of a change here. So we're at 46% of non-detect, and we're at 42% for less than 5, and we're at 6% for less than 10. So we're at 88, 94% that's under any type of detection. Now, any type of reporting from regulatory standpoint, one of the things we do notice with kitchens, they tend to have different fixtures. They tend to have, in some of these locations, a little more commercial oriented sinks and faucets compared to our bathrooms and our hand sinks, which are typically more of just a very much residential grade. So that's I'm gonna say that's one of the things that we're noticing about the fixture types. Okay. Water fountains. Now, this is one that really, I'm gonna say, kind of blew me away, and I just assumed we would find a lot more lead in these water fountains from the results what we're seeing. But as you can see here, what is this? 2, 3. So we're at 97, 96%, 97%, basically any type of uh, reporting level. I've just been fairly amazed, which I think it's a very positive thing because this is where we expect kids to drink water. It's from the water fountains. So this is really good. Like I said, this is good news. This is a positive, so it gives a little peace of mind when we think about what children are drinking at childcare facilities. All right, utility sinks, a little bit of a different creature. Now again, just about every facility is going to have a utility sink that's in some type of back room, some type of janitor's closet. Uh, that's what it's for. And very similar to the sinks, you see some very commercial, industrial grade faucets, connections at these locations. And again, it's especially when we're collecting that first 250 milliliters, it's about that faucet. What is it sitting in overnight? So here, only 23% non-detect, 45% are in that less than 5, 11% are under 10. So that's 34, 79%. So you see we're that percentage is dropping. So we have a lot more samples that are exceeding that 10 ppb, or even exceeding the 5 ppb, which we notify people of. But this is one of those faucets that we very much we have started to tell child care facilities, do not allow people to drink from this. And we're telling a lot of our utilities that are going to be collecting samples that, these are not the locations you need to pull your lead and coppers from. All right, first draw samples from a follow-up. So what we typically will do is we have a facility that has had a spike. So if it is pinged 5 or above, we'll notify them. And a lot of our facilities, even prior to us being able to assist financially with remediation, they would replace the faucets themselves. So we like to go back, do another follow-up sample for them to try to assist. And I'm going to say kind of giving them data, but also peace of mind of is it worth what we're doing? So follow-ups, the percentage of non-detects goes down, but we have a much higher percentage less than 5 ppb. So we're at 70, 60, 70, 72, 72% below. And if you add our 5, that's 85% that are under that 10 ppb. So you're seeing this, I'm gonna say, very much improvement, but it still lets us know that there's something there. And again, these are with facilities that actually had a spike at one point in time. All right. Flush draw. Now this is what we collect, a 250 milliliter sample, and then we collect a second 250 milliliter sample. So this is further down, so very much not exactly what is setting in the faucet. You're getting a little bit further down the supply line there. But it's good to see the non-detect increased. The non-detect increased 46%, the less than 5 is at 42%. And then the under 10 is at 10%. So that's 40, 88, 98. So 98% below any type of reportable level with that flush draw sample. All right. I know this may look a little, I guess, a little overwhelming or a little cumbersome here. But what I was wanting to draw from this is, for one, when we look at our flush draw samples and we run the number from the initial draw to the flush draw, we're seeing that change in lead reading. We're seeing that change from the first 250 mil to the second 250 mil. And what we can say from that is, and we've run the numbers doing a two-tailed t-test, this is statistically significant down to the 0.01 level, that there is a change, that there is a difference between the first and the second. So when we start thinking in this vein of remediation, and we'll get into this in a second, we start thinking in this vein of low-cost options that we can do to reduce and or eliminate the exposure of lead, simply flushing these faucets. This is a data-driven justification for why we would use that. All right, I dropped in here the language that we are literally putting into our quality assurance plan and our work plan related to how we are assisting uh, our facilities. So, a couple of things to point out. And I know y'all are all going to have access to these slides, so you can go back and read it later if you'd like to. Um, Based on the funding we have and based on what we've seen as far as childcare centers and the number of faucets that had an exceedance over that over the 10 ppb, we could easily afford to offer any system up to $200 per faucet to get it replaced. Now, we're not limiting anybody. If they've got one faucet, they're eligible for 200. If they've got 10 faucets are eligible for 2,000. So, but from our end, we have to have some justification or some validation, I would say, that it is getting done. So as you can see on this left side here, when we get to some bullet points, what we ask of the facility, for one, they got to let us know that they're interested in doing it. They have to select the faucet that they want. We do not dictate that at all. They would find their own plumbing professional. Again, we do not do that for them. And again, with just the geography and the variability across the state, to me, that's the wisest way is to let them figure their own. They would actually take pictures before and after so that we know which faucet it was, make sure that it was actually replaced. Moving over to the second side of this, and again, we're going to get into this in just a minute, but what we require of them is to make sure it's NSF ANSI 372 certified, and that is a labeling, and I've got a picture here in a second, that any homeowner, any custodian, any childcare center owner, anybody can recognize once you've seen it. And again, there are multiple NSF ANSI certifications. 372 is simply the one that's related to lead in drinking water, or lead and reduction in the faucets and fixtures themselves. But we need to make sure that that is certified, because that is where we're trying to kind of follow the new laws as far as lead reduction. All right, so the next steps that we take, they'll receive notification that their lead reading was at or above 10, so that's kind of your trigger. They inform us that they're interested in replacing it. They provide these pictures so that we can see it before. They give us validation that it is the NSF ANSI 372 certified by taking a picture of the faucet, because it's going to be on that box or packaging that they may have. Provide a picture to us after, once the faucet is actually in place, and then they simply send us a copy of the invoices so that we can get those facilities reimbursed. All right. So when we think about lead, and this may be old news, for some of y'all, but just to try to make it as clear, I pulled this from EPA site. I figure this is the best way to look at it. When we think about how water is getting into our homes, so many people, I must say, don't understand or don't appreciate all that goes into simply having good, safe, clean, uninterrupted water coming into your home for your showers, for your bathroom, for your drinking water, for your cooking and cleaning. We have really come a long way in the last 100 years in what we have and what's available. So, starting here, you'll have a water main somewhere, depending on the utility, depending on the age of the utility. Your water lines may be out in the middle of the road. I know where I live, it's an older street. A lot of those homes were built late 1800s, early 1900s. Our water main is in the middle of the road. My best assumption is that back when they were putting the water system in, the roads were not paved, and that's the easiest place to put a water line. So they put them in the middle of the road. Now it's paved over, so anytime you have an issue, they have to dig up the road. Not attractive, really. But anyway, that is the way it is. So from the main, um, now that we're in, we meter the water that moves into the home. So there's going to be a line from the water main to the meter. And I say this, and again, I haven't been tarred and feathered yet, but I try to be real. There was a period of time in American history in which lead service lines, those lead goosenecks, just the lead lines themselves, they were great because it was very pliable. You could bend it, you could move it around. It gave you a lot of flexibility with installations. Like it was a useful tool. So we used it, and they were used a lot all across the country. Now that we typically see or use what's called a service tubing, very similar as far as pliability and moldable, but not of a lead material. It's more of a plastic poly material. But anyway, but there still are some lead goosenecks out there in service from your main to your meter. All right, then from the meter to the house, and there's a little bit of discussion going on out there in the world, especially as we discuss lead. But from everything I've seen, known, understood, and studied and discussed over the last 20 years, uh, from the meter towards the house is the homeowner's responsibility. The water utility itself, of course, is responsible for the quality of water, but their responsibility as far as infrastructure stops at the meter. So from the meter in, again, depending on your age of your home, may be different types of material. You may have PVC, you may have galvanized, you may have PEX, you may have any types of lines. Even when you get some of the internal, you may see copper, you may see some of those lines, but you may see a variety of materials that water may come in contact with as it enters your home. In a perfect world, when the main line is set and it's tapped, from there it's service tubing, and the only type of metals that it may come in contact with would potentially be your meter and then your faucet. But that's not always the case with everybody. So just kind of making you aware. Now, again, I love this visual as we move in. You see the meter, the different types of service lines that may serve the home. And then once it taps into the home, you may see different types of materials there. So again, not that that should alarm anybody, but just being aware that your water is coming in contact with potentially different forms of materials. But as I'm telling you now, in a perfect world, the only time your water would come in contact with any types of these metals would be your meter that's in your yard, which is that connection between you and the utility, and then your faucets and fixtures themselves. All right. So when we think about what I'm calling these immediate actions, these are very much just no cost, but just steps that you as a homeowner, as an owner, as someone that would consume water could take. So first off, any fixtures with elevated lead levels, just to note, if anything, do not use for cooking, do not use for drinking, do not use for mixing formulas. Uh, we do have, and we've seen these little, like kind of little wrap stickers you can put on a faucet that just says not for drinking or cooking, so the people know that that faucet has an elevated lead. So also, as you've heard me talk about, your public water supply is responsible for your water quality. Now, the plumbing that you may have in your house can be a cause as well, but the public supply, if you're on a public supply, they should be providing some type of corrosion control to keep the water's pH at a certain level. So it may be valuable if you are having some exceedances just to let them know that you're seeing it, because there may be something with their system that they need to check. I'm sure they're already checking it, but it never hurts to let them know. I'm always an advocate for letting your water utility, water operator know what you're seeing or finding. All right. Some other measures that we can take. The first that I would say is kind of right off is flushing your faucets. So one of the things that we always tell childcare centers, especially when our average is about 12 faucets per facility, and we see about 1 in 12 will have an exceedance. So if we know what faucet it is, as a safety measure, every morning you can simply turn that faucet on, let it run for at least a minute, flush any type of lead that may have accumulated overnight out of that faucet. You can definitely use bottled water for drinking. That is an option. And then point of use filters that can be added to your faucet. There are multiple options that are on the market. So you can go to any, I'm going to say, trusted store, Home Depot, Lowe's. You may have a good water utility or a water specific uh, business in your town you may be able to go to. My biggest statement that I always tell people when we start talking about filtering is um, make sure you know what your filter is filtering for. Because many times people just see water filter and they assume that that's going to cure everything. Well, do know water filters almost each have a specific, I'm gonna say, parameter or panel or metal or contaminant that they are trying to filter for. So just be aware of what you're purchasing and make sure it's filtering for what you want it to filter for. So if you're wanting something to filter for lead and copper, make sure when you purchase that filter that it is a point of use lead and copper filter. All right, so when we start getting to a little more costly, some actual solutions, as you heard me say, in a perfect world at the water main, you would have newer service tubing, not lead gooseneck, coming into your meter. So if you do actually have lead service lines, now again, there's a lot going on around lead service line replacement across the country right now, and your system should have determined if it actually has lead service lines in it, and there's going to be a mission to get those changed out over the next coming years. And that'll be a great way to definitely reduce that exposure. So just be conscious of that you may see it or hear about it. And that's another good reason to let your utility know if you're having any lead readings. You may have lead service line, you don't know it. And then also replacing any type of, if we start at the fixtures, replacing any type of fixtures that may have exceedances, because everything now should fall under that. I think it's 0.025%. I believe that's right, of what percentage of lead could actually be in any type of those faucets themselves. Replacing any type of internal plumbing. So once you leave the meter and start coming towards your house, is there any lead piping in there? Are there any of the galvanized lines in there? You may want to reduce, or maybe you want to have a uniform, uh, I guess, the internal plumbing. You may want to have uniform internal plumbing from the meter in. Those are costly, but that could be a great way to definitely reduce your exposure. Reconfiguring plumbing, which I just talked about that. So again, there's multiple stages from the main to the meter. You'll probably see that take place with your utility from the meter to the house. That would be something that would kind of require some construction, possibly because it's going to be buried. And then depending on where you are in the country, depending on that frost line, yours may be 14 inches deep, maybe 3 foot deep. So again, probably a little more invasive there. And then once you get to the home plumbing, depending on if your plumbing is running underneath or above, a little bit easier to access, but still it would require some work and some funds. All right, you heard me talking about the NSF, ANSI, and the NSF 32 certification. So do realize, kind of hinge on, so NSF, the National Sanitation Foundation, and then the ANSI, American National Standards Institute, they have multiple, I'm gonna say certifications. 372 is the one, means a faucet is complying with those lead-free requirements. So if you see something that says NSF, ANSI 58, guess what? That's not related to lead. So don't simply go on the NSF, ANSI. Make sure it has that in addition to the 372. All right, and this specifically ensures that the product's weighted average lead content is no more than 0.25% for most products and no more than 0.2% for solder's and fluxes. So there is a small, very small amount that is going to be in fixtures and faucets, but as you see, 0.25% is 0.0025. So it's very, very, very minimal, but there is some there. But this is a key when it comes to any type of faucet replacement that we're going to see. This is what we hinge on because we don't want to spend the money to replace a faucet or fixture if it doesn't have this certification. And this is really the only thing we have to go off of right now is this certification. Something else you may see, and I don't think I put it in here. You also may see a symbol for US, and you may see a symbol for, I think it'll either be C or CAN for USA or Canada, and it's basically just meaning that it's certified in both countries. So you may see that in addition, but if we hinge on anything, NSF ANSI 372. That is showing that it has been certified and inspected for this lead-free requirements. All right. So taking it just a little bit step further, when we think about lead, when we think about faucet replacements and those steps that we may actually take. So if I'm a homeowner or if I'm a facility owner, and I'm taking it upon myself and I'm not participating in any type of program. What I would do is I would get my water tested at each of these facilities using the process that you heard me talk about earlier, where you have a flush the evening before so that you bring in good, fresh, treated water into your system. You allow for an overnight stagnation period, and then you collect first draw samples from your faucets. If you have anything, and again, you can use the 10 or the 15. Some people would say it's 0, but get your water tested for lead. And if you see any reading that makes you uncomfortable, and I would say, again, using the number that we have as a program of 5, if you see 5 or above, that would make me interested in replacing that faucet. All right. Then I would look for faucets aesthetically pleasing to my home or facility or location, but make sure you see the NSF ANSI 372 certification on it. Uh, Replace the faucet itself. Um, and this should help, if not completely eliminate it. But I would very likely, you don't have to, but I would very likely get it tested again just to see if it was completely reduced, if not, by how much. And if you do happen to still see some lead, it's possible that you've got either a corrosion control issue within the water supply itself, or you have, I'm gonna say, and or you have internal plumbing, some other plumbing components that your water is coming in contact to prior to making it to your faucet. Um, a couple of things that I wanted to touch base with just to kind of show for future reference if anybody needed it or wanted to, but even though this program runs under our heading of SIP Safe, it is related to lead. It is related to lead testing, lead in drinking water, remediation. So there's a lot of good resources that y'all can have and utilize from what we have here. So a lot of what we talked about is in these publications today, how to SIP safe, dealing with lead facts. Again, I'm just kind of giving you a screenshot, but I'm also providing you the URL so you can dig into these publications yourselves. Lead poisoning in children. So this is really directed more towards how lead in drinking water and other sources can affect children. And sadly, we have to make these things known so that some people realize the importance of reducing or eliminating lead in our drinking water. Healthy Homes Checklist. This is just a great way to allow people to walk through um, what to look for, what to see, what to do related to eliminating or reducing lead in our homes, in our water. One of the great things I like about our programs, we also created a lesson for children. We created this so that schools and childcare centers could potentially use this to educate their kids. So we feel like if we get kids aware of the program at a much younger age, aware of lead and drinking water at a much younger age, uh, they will help and they'll be champions along the way. I've liked adding this lead and copper rule revisions on the back end just so that we start seeing where we're going towards the reduction of lead in drinking water and kind of the areas that we're targeting and some of the additional sampling efforts that we're taking by. So we're giving all public utilities 5 years to sample all schools and childcare centers. So basically 20% a year within their public water supply. All right. And with that, I'm Jason Barrett, Interim Director here at the Mississippi Water Resources Institute at Mississippi State University. Thank you.
Thank you very much, Dr. Barrett. That was very informative and a wonderful presentation. I appreciate you taking your time and putting that together for us here at USET. And I hope everyone out there got something from it. I'm going to open the floor up to any questions.
All right, I'm open.
Actually have a quick question. I'm curious to know if you guys have started to complete any remediation activities, and if so, what are some of the successes that you guys have been having, and also some of the challenges that you've seen?
Ooh, so to answer your question, yes. And we're I don't know if you'd call it phases or just different processes. The first several years of this program, probably I know the first 4 years of this program, we did not have any funding for remediation, even though we would offer people the recommendations of what they can do. So we did see a good many systems, and I could get you those follow-up numbers if you wanted them. We did see a good many systems take it upon themselves and replace fixtures within their facilities, and we would go back and do follow-up sampling. So if you recall in the PowerPoint where we saw the follow-up samplings and we saw the reduction in the lead, those follow-ups were from facilities that had replaced faucets already prior to us having a financial incentive in
Hmm.
place. So that's probably the biggest success. Now that we have some funding in place, yes, we're hoping that more facilities will take advantage of it and replace faucets themselves. Yes.
Nice. Have you guys had any completed any activities such as like going to town hall meetings or host or attending let's say like health fairs or things like that that are at schools to increase outreach and awareness of the program or outreach or awareness of lead poisoning, lead reduction in children?
We have attended several of our trade association meetings and we've done presentations, we've set up vendor booths, but we have not gone to any town halls and we've not directly gone to any schools. We've been basing it on the trade associations themselves uh, that would, I'm gonna say, mainly allow us access to get into a school or a child care facility themselves.
Very good. Are there any more questions? Alrighty. Well, I'm going to thank you again, Dr. Barrett, for taking the time out and doing this presentation for USET. We really, really do appreciate it, and we really enjoy hearing the how you all have handled the project and everything that you all have done so far to make sure children have clean and safe water. With that, we will wrap this webinar up, and thank you all very much who attended. And we'll get this posted online, and see you all soon. Have a great
All right.
day.
Thank you, Ben. Thank you, Jakira.
Thank
Thank you,
you.
Dr. Barrett.